In this section, I'm going to go over some variable operators, and we're going to focus on arithmetic with these variable operators. There are 5 operators that you can use for arithmetic in PineScript. We have addition, subtraction, multiplication, division, and the modulo operator. Now I'm going to go over each one of these and give you guys some examples so you can understand how to use them. So addition and subtraction, these are pretty straightforward. We have this first line here in line 15. All I'm doing is adding 2 constant integers together. 2 plus 2 equals 4. Very simple. And here, subtraction, I'm just using basic subtraction and addition symbols. 2 minus 2, constant integer, 0. Exactly what you'd expect. You can do the same thing with floats. 2.0 plus 2.0. You can even add floats and integers, no problem. The result would be a float. Like here, float int 2. 2 is an integer, and this is a float. 2 plus 2. The result would be a constant float. We can also add series and integers or floats together. The result would actually be a series float. So across every single bar in the closed series, you would have that plus 4 across the entire thing. And if you add an NA variable to an integer or a series or a float, it would actually end up being, the result would be NA. And same thing if you subtract it. So if I plotted always NA, if I add this to the chart, let me save it and add it to the chart, the result will always end up as NA. So there's a way to actually look for NA variables when you're doing calculations, and you check, you go, okay, is this an NA variable? If it is, then do this. If it's not, then do that. And yeah, see, it's always NA. At least this first one here. So if we look at the data window here, you'll see plot, which I didn't give it a title in here, but it's the first plot I have, and it's always going to be NA. Even though I have 2 here, I can even go in and add plus close, and you can stack on operations, minus 4, and if things are starting to get tricky, you can put things in parentheses. Whatever is in the parentheses gets done first, and then on the outside. So close minus 4, then plus 2 plus NA, and the result, because there's an NA in there, will always be NA. And you see this plot, what do you know? It's NA. Another cool feature when you're using the addition, the plus symbol, is you can concatenate strings together, which basically it's like adding 2 strings together. So here we have string 1. I just put them in identifiers. You don't have to do this. And current, and notice I have a little space here, current range. And then this is the concatenation. I just labeled it concatenation. And all it's going to do is just going to make 1 string. And I could actually, let me plot that. Okay, close, and then title. And here you go. The title is this concatenation, which is actually current range. Right here. So you can do that. That's the only operator that you can work with strings with. You can't use a minus. So that's a nice little feature of the plus symbol. Also, with the plus and minus operators, they're unary. So you actually don't need 2 operands on each side for this to work. This is an operand, and what? Let me see. This is an operand, this is an operand. So you can actually have just 1, and all this does is it negates this expression. So this is the number 1, and now this identifier is going to end up being -1. With the plus symbol, it actually does nothing. It's just for symmetry. Those are the words of PineScript docs. So the plus symbol really does nothing. It doesn't add 1. You'd think it would, but it does nothing. So it's just there for looks. And if I go ahead and plot these, actually it's already plotted. You can see them right here. 1, -1. So unary addition, plus 1 does nothing. It stays at 1. It's green. And unary add, you can see it here as well as there. 2 different places. And then the -1 actually turns it negative. So let's do a little example use case here. We can actually find the range between the high and the low, which is actually something you might want to do and use when you're actually trading. So here we have, I'm taking the high series, I'm just minusing it from the low series. So it's going to create a new series of the difference between the high and the low. And we're going to call it the range. And I could just plot that as is. Range, title equals range. Right, I could just add that. And here we had the difference between the high and low all the way through. 11.10, that's the current range. And actually I did it down here too. And I also, for some extra functionality, we had the change. So I'm taking the range from yesterday and subtracting that from the range of today. And this does it all the way across all the ranges. So it'll always be, today's range subtracted from yesterday's range. And that's the change in range. And then there's also a function built in the Pine script that basically can do that for you. So, either way works. Whatever way is good for you. You can use this function. This one also allows you to select more than just yesterday. So you can do 2 days ago, 3 days ago, 4. I can do that here too. So it's kind of the same thing. Exactly the same. I'm just showing you there's many ways to skin a cat. I've never skinned a cat before. I don't even know why that's the same. But yeah, here we go. Here's the change in range. And I'm actually showing right here in this title, I'm actually doing some string concatenation within the title. You can actually do this within parameters. It's kind of messy, but you can do it. This equal sign. So change plus string 2. And I think string 2 is up here. Range. Change range. Same thing here. And I actually added another one after this identifier, by. And we can see that. Save that. Look at the data window. Current range, change range by. And see how that's the same exact thing, same number. So it doesn't really matter what you use. It's up to you. Moving on to division and multiplication. So pretty straightforward here. There are a couple intricacies that you should be aware of, but for the most part, division is division. This 2 divided by 2 equals 1. Same with 2 times 2. Use a little star right here, the star operator, and the asterisk. That's going to be equal to 4. Same thing with floats. You're going to get a float returned. Same thing if you're multiplying floats, and if you're dividing an integer by a float, you're going to get a float in return. So you can also divide by closes, and this divides by every single close across the entire series. I think you understand that. And then we have this one. This one is closed times 4. So this bar is closed times 4, this bar, this bar, this bar, and so on. And the result will be a series float. And like the addition and subtraction, if there is an NA variable, then the result will be NA. So it doesn't matter what you're doing. If you have an NA in there, then the result will be NA. And if you want to avoid that, there's a function built into Pine script. I believe it's called just NA. And you can put this around your, say you can put it around here. Because maybe you won't actually know if there's going to be an NA variable within your calculations. So you'd put something like this in and see how it says test value if it's NaN. And basically it's going to return a Boolean or a series boolean, and it's going to say, okay, true, false, and then based on that condition, you can do things like you can actually do your division or multiplication or whatever it is you want to do. Okay, so things you can't do, you can't divide by 0. This will throw an error if you're doing 1 divided by 0 or anything divided by 0. And you might get slipped up on this right here. So if you're doing integer division, say like 1 divided by 2, you would think that would equal 0.5, but it doesn't automatically cast to a float. So you're actually going to get, I believe, 1 with this. So you need to, if you're going to be doing division with small numbers, just use floats, because it's just going to take, it's not going to actually give you the right values here. So it's actually 0, plot 0. So it should be 0.5, but it can't show 0.5 because it's 2 integers. Here, good fraction, you have the float divided by the int, same thing, but it actually casts it to a float because there's a float in the expression here. But if you want to do your math really good, just use 2 floats so you avoid any of these issues. Moving on to an example use case using everything we've learned up to now, finding averages. So bar sum, which is just the high plus the low, just add those 2 together, and then we can divide those just like that, and then we get the average between the high and low. So it's kind of like the average price right here. We could also do the same thing here without placing these 2 values in this identifier. We can just place them in the parentheses. So the addition is done in here, and then it's divided by 2. And the result will be a series float of the average between these 2. There's also a built-in variable called HL2. It's the same exact thing, it's just a little shortcut. But at least this way you know how to do it. And if we plotted that, it would just plot the average. I don't think I need to show you guys that, but I'll leave this script in the resources so you can copy and paste it into your Pine editor and you can mess around with it. We can also do the same thing with more values. I don't think there's any limit to this, but this is a common one where you get the average. It's so common they actually have a shortcut for this one as well. It's called HLC3, which is high, low, close divided by 3, and we can plot that as well. Now if you want, see this value up here, this percent change, we can actually do that within PineScript, and that is the today's close. So this current value, it hasn't actually closed yet, but we can grab it and we can subtract it by yesterday's close, which this 1 represents 1 bar back, which is right here. So this close minus this close, let me make that a little closer so you can see it. So this current close, it's still moving, minus right here. And we divide that by the current close, multiply it by 100, and we should get the percent change to plot. Nope. Let me comment this out. High-low average is already defined. Okay, I defined it 3 times in the same spot. That's why I use different names for your variables or your identifiers. All right. So double click that, bring it to scale, and negative 0.21. And look at that, it's exactly like this. So there we go, we made our own little percent change indicator. Okay, moving on to modulo. Modulo, I don't really know how to pronounce that. If you know, let me know. But this is the remainder for division. So 5.0 modulo 3, which is actually going to be, here I had the math here, so if you're doing 5 divided by 3, you get 1, and 2/3. That would be the fraction, 2/3. And the modulo would be the numerator of that, which should be 2. So you can do integer modulo, and 2 divided by 2 has a remainder of 0. There's nothing left. And a 2 float divided by 2. I don't know why that's division. Here we go. That should still be 0. And this should still be 0. Float int mod. Not sure why I have 1 here, because there's no remainder when I'm dividing by 2, even if it is an integer here. And we can check that. Let me just do this. And we'll do this, and we'll do title, question mark, because why is that there? And what do we get? Well, it's hard to tell here. That's why we, C0 right here. Question mark 0. So let me get rid of percent change and modulus 5. And we can also do series modulos, which does basically the same thing as any other operator with the series. So you're still going to get a series float as you're returned, and it's just going to give you the modulus across the entire series. So it'll be different everywhere. And the same thing with NA values. You'll always get an NA returned. So integer division with the modulo, you're going to get a 1 here, because the remainder is actually going to be 1, and it works here. In this case, I know we talked about using floats for dividing, but in this case the modulo actually works between 2 integers. See here? So if you're looking for the fractions and you only want to use integers for some strange reason, you can get your fraction, your remainders, by using the modulo operator. And where would you use this? Well, you can use it to maybe make your own clock. You can do a Google search on when you'll use the modulo operator, and there's a couple good use cases for it. So if I want to grab the time, this is a built-in value in PineScript. It just gives me the time in milliseconds since January 1st, 1970, UTC. So I divide that by 1,000 to get rid of the milliseconds and put it in seconds, and then divide that by 3,600, so I get it in hours. Now I have hours since January 1st. And then if I want to turn that into military time, I just divide it by 24. Well, I get the remainder if I divide it by 24, and the remainder will actually give me military time right now. So let me plot this. Military hour time. M time. And it'll be 0 through 24 for every hour. I'm on the 4 hours, so it's actually only going to show in 4-hour intervals. But if I go to the 1 hour, I get myself a nice little clock all the way up to 24. Well, 23, because on 24 it goes back to 0. M time. So right now it is 8 p.m. UTC. See the clock right here even says 2000, and we have 20. So that's how you do that. You can also do 12-hour clock by using the modulo for 12. So say if it was 15 was the hour. Divided by 12, we get 3 p.m. Let me plot that so this makes a little more sense. So now this is a 12-hour clock. So it's like a little filter. You can think of the modulus operator as like a filter. So it only allows these intervals of 12 to come through, or up to 12. And if I want to grab the minutes in an hour, I can do the same thing here, get the time, divided by 60, divided by 1000 to get rid of the milliseconds. So now I have 60 minutes, and then do the modulus for an hour, and I have minutes. I'm going to plot minutes. And I gotta get rid of these other plots or give them a color because it's kind of hard to tell what's what. 12-hour clock, undefined. This should be the only plot remaining now. Okay, 0. And this is because I'm on the 1 hour time frame, so the minutes always start and end at 0 on the 1 hour. So I need to go down to something lower than the 1 hour time frame. And this is the 15 minutes, so it's going to be in intervals of 15. 15, 30, 45. 5 minute and 1 minute. All the way up. So that's just a simple, just a way you would use the modulus operator. There's other use cases, but just to show you, it's there and you can use it.